Hello dear students. In the previous session we have learned how graphs are represented using adjacency matrices, adjacency lists and edge lists. So in this session we will study different types of graphs. Every real world network is not the same. Some networks have direction, some have weight and some have multiple connections while other have positive and negative relationship. By end of this session, you should be able to identify the appropriate graph type for any real world application. Here are the few types of graphs: null, empty, directed, undirected, mixed, simple, multigraph, weighted, signed and graph, web graph. First of all, so the first type of graph is null graph and empty graph. So a null graph contains no vertices and therefore no edges. So that g of v comma e, so vertices equal to edges equal to pi, which is a null. And then imagine an empty classroom with no students. Since there are no students, there can be no friendships. That is a null graph. And next one is the empty graph. So empty graph contains vertices but no edges. Example, suppose 5 students have joined a new class on the first day. None of them know each other. We have 5 nodes but no friendships. That is an empty graph. Remember that null graph have no nodes, no edges, and empty graph is nodes, edges but no edges. So the next one is directed, undirected and mixed graphs. So relationships can be of different types. So undirected graph. So the first one here the first one is directed graph. The relationship has a direction. Example, Twitter. I may follow a celebrity. The celebrity may not follow me. Hence the arrow goes only in one direction. So and then undirected graph. So the relationship works both ways. Example, Facebook friendship. If A is a friend of B, B is also a friend of A. This is the undirected graph. There is no arrow in the edges. So and then mixed graph. Mixed graphs are directed and somewhat undirected. WhatsApp business. Friendship is mutual. Money transfer has direction. This creates a mixed graph. So the next one is simple graphs and multigraphs. A simple graph allows only one connection between two nodes. Example, one friendship between two students. A multigraph allows multiple edges. Example, between two people there may exist friendships, colleague, relative, business partner. So all these relationships can connect the same two people. Therefore, multiple edges are required. This is why multigraphs are important in social network analysis. The second one is the multigraph type. So the next one is weighted graph. In some application, all edges are not equally important. Suppose airports are nodes. Flights connect airports. Should every flight have the same importance? No. Each edge has a weight. The weight could represent distance, cost, travel time, fuel consumption. Google Maps also uses weighted graphs. Roads are edges. Distance or travel time becomes the weight. So this is the weighted graph. So the next one is the signed graph. Sometimes relationships are positive or negative. Instead of storing large weights, we simply use +1 and -1. So the examples include Facebook, friend plus, enemy minus. In politics, supporting persons are plus, oppositions are minus. This type of graph helps us study social behavior and conflicts. So the next one is the web graph. Now let's see how the internet is represented. Every website becomes a node. Hyperlinks become edges. If website A links to website B, there is a directed edge. Since websites may contain multiple hyperlinks, the web graph is usually a directed multi-graph. Google search originally ranked websites using this graph. So the next one is this is the structure of the web graph. So it follows the bow tie structure. So in and SCC and then out. So these are the disconnected components. So the next one is the connectivity in graphs. So now, so far we have learned graph types. Now we study movement inside the graphs. Can we travel from one node to another? Yes, this introduces the idea of adjacent nodes, edges, walk, path, trail, tour and cycle. So the first relationship is adjacent nodes and incident nodes. Two nodes are adjacent if an edge connects them directly. Example, if A directly connected to B, then A and B are adjacent. Now consider edges. If two edges share a common vertex, they are called incident edges. These connects help graph algorithms move through networks. So the next one is walk, path, trail, tour and cycle. So the first one is walk. A walk simply means moving through connected edges. You may visit nodes repeatedly, repeat edges or return to the starting point. Example, walking around your college campus. You may pass the library multiple times. That is still a walk. So explain open walk. So starts at one place and ends elsewhere. Closed walk in the sense starts and ends at the same place. This is the walk. So these are the nodes V1, V2, V3, V4, V5 and V6. So the blue line represents the walk. So we are traveling from V1 to V5. So the length of walk is number of edges connected. So the next one is trail. So trail is slightly stricter. Edges cannot be repeated. Nodes may repeat. Imagine delivering parcels. You never travel through the same road twice, although you may revisit a city. That is called a trail. So this is our vertices V1 to V5. We are moving from V1 to V6, but we are not repeating the edges. This is the trail. So there is a closed trail is called as a tour or circuit. So the next one is path. Path is even stricter. Neither nodes nor edges repeat. Every location is visited only once. And the next one is cycle. A cycle is a path that returns to its starting point. Example, school bus starts at school, visits all stops and then returns to the school. This forms a cycle. So the vertices V1 to V6 we are having. So we are visiting from V1 to V2 and then length of path equal to 4. So next one is the Eulerian tour and Hamiltonian cycle. These are two famous graph problems. Eulerian tour. Every edge is visited exactly once. Remember the Königsberg's problem. That is Eulerian. Hamiltonian cycle. Every node is visited exactly once. Notice the difference. Euler focuses on edges. Hamilton focuses on vertices. Students may often confuse these two. So the Eulerian tour is it represents or it focuses on the edges and Hamiltonian focuses on the vertices. Both represents every edge is in Eulerian, every edge is visited one. In Hamiltonian, every node is visited exactly once. So the next one is random walk. Suppose a person stands at a road junction. Instead of choosing a fixed direction, he randomly selects one road. Then again at the next junction, he randomly selects another road. This process is called the random walk. So examples or applications of the random walk are Google PageRank, robot navigation, and stock market simulation. So thank you students. In the next session we will see the another types of relations.